This question asks us to find the horizontal asymptotes of this function. So that means we have to calculate two limits, right? We have to calculate the limit as x goes to infinity of f of x. And also we need to calculate the limit as x goes to minus infinity. These are, if this turns out to be a number, then y equals that number is going to be a horizontal asymptote at infinity. And similarly over here, if this turns out to be a number, then y equals that is a horizontal asymptote at minus infinity. You know, it's really a different thing to have a horizontal asymptote at infinity and a horizontal asymptote at minus infinity, right? For example, if you had a graph maybe like this, let's take arctangent, right? If this is arctan, notice this is pi over 2 up here and minus pi over 2 down here. For arctan, y equals pi over 2 is an asymptote at plus infinity, but y equals minus pi over 2 is an asymptote at minus infinity. So just keep the distinction between those two different kinds of horizontal asymptotes in mind. All right, let's calculate these two limits. Why don't I write my equal sign here instead? Okay, so let's substitute the formula in there. Now when x goes to infinity, x is positive, right? So, well, how about I do this? Let's pull out the, let's rewrite x as the root of x squared. Okay, that's true. And then let's make it make it all under one root sign. All right, and now let's divide everything by x squared. So we get 1, this is also 1, and this is 9 over x squared, right? Now the thing is, when x goes to infinity, 9 over x squared goes to 0, right? So we can now do the limit. This is 1 over 1 plus 0. And this is just the root of 1, which is 1, so this is 4. Okay, so we've actually discovered a horizontal asymptote. So y equals 4 is a horizontal asymptote. I'll just abbreviate that as HA. Now the tricky part comes over on this side, actually. The first step is the same. We're gonna replace f of x by the formula that it is. But the thing is this, I cannot replace x by the root of x squared in this situation, right? Let me explain that a little bit. You know, if x is positive, then we know that the root of x squared, or we know x is equal to the root of x squared, right? And what about in the other case? Let me actually just get myself some more room here. 1 second. All right, what about this case? If x is negative, what can we say? Well, then x is actually equal to minus the root of x squared, right? If you think about that, you'll be convinced of it. And that's what we want to replace x by in this case. So let's do that. So instead of x, I replace it by minus the root of x squared. And since x is going to minus infinity, I definitely know that x is negative. All right, let's see what we get. Well, really, it's the same thing, isn't it? I just have a negative 4 in front. And then I have the root of x squared over x squared plus 9, just like here. And I'll just skip that one step and do the algebra right away. And now I can do the limit. It's 1 over 1 plus 0. And that all works out to be negative 4. So it looks like we get another horizontal asymptote. Y equals minus 4 is also horizontal asymptote. Actually, you know what? I should be a little bit more specific here. Y equals 4 is a horizontal asymptote at plus infinity. And here y equals minus 4 is a horizontal asymptote at minus infinity. And this kind of gives us a little bit of idea what the graph looks like, right? If this is the xy axis, this is y equals 4, let's say. And this is y equals minus 4. I know that at plus infinity, it's maybe like around here, and at minus 4, it's around there. In between there, I'm not sure what happens, but at least we kind of know the end behavior as x tends to infinity or as x tends to minus infinity. But this question doesn't ask for the graph, so we don't have to worry about that. I just wanted to mention that, just to say what it really means. All right, so these are our two answers for this question.